So we're almost at the end of the chapter already. So just now we have looked at the basics of AC, and then after that series and parallel. So now we just look at some examples here. Okay, so this is a circuit. It gives you an R and an L. Alright, so if I want to get a total impedance, basically it means that I want to get the total impedance of all my components here. I can't call it resistance, right? Because resistance only indicates its resistor, so I call it as impedance. So ZT will basically be my ZR, basically just my R, plus my ZL. Remember my ZL? My ZL is my J omega L, or J omega stands for 2 pi FL. Alright, so if I want to use my Ohm's law, if I want to get my I, basically my I will just be my voltage source, which is my E divided by my Z. Alright, in this case my IR and IL is the same, because for any given series circuit, the current that flows through any element remains the same. Alright, so if I'm talking about real power basically means, remember what we have mentioned earlier, it means that I get the power through my resistors. Therefore, it can be found by I square R or V square over R. Okay. Reactive power, on the other hand, in this case, I only have my L. Alright, so it can be equivalent to I square XL. Alright, or V square over XL. You can see that Ohm's law repeats again and again the same, regardless of it being R, C or L, only that the representation is different. And of course, we need to be very, very sure to know the formula for my XL, my XC, and so on. If it's RC, the same, instead of ZR plus ZL, I just replace it with ZC. Ohm's law, how I get it, still the same way. Alright, now real power, again the same, nothing changes, but you see reactive power now, it becomes I square XC. Remember my XC is negative J 1 over omega C, right? 1 over omega C is also 1 over 2 pi FC. Alright, very important for us to know the formula. If it's a combination of all these three, impedance, add all up together, you know ZL, you know ZC. Ohm's law, you just take the V, divide by the whole impedance. Alright, if you want to get voltage across each individual component, as long as you have the I, you have the impedance of each component, you will manage to get the V across it very easily. Okay, same goes for here. In this case, real power is only my R as usual, but reactive power, Q, I have L, I have C. Therefore, I need to take into account both together, right? So we just add all, find each individually and add those up together, and that will be my reactive power. Alright, how do we know? If any of you have question like, oh, how do I know whether it's actually to calculate all or not? If they say reactive power of the circuit, basically means you have to take into account all the components that you have, all the reactive components, which means your XL and your XC, unless they're talking about reactive power across the inductor. So it means you only want to find for the inductance one, or reactive power for the capacitor. Or sometimes they say power through capacitor, but that also indicates that you need to know that we're actually looking for the reactive power. But otherwise, if they ask you to find for the circuit, it means that you have to take into account all the components. Alright, so if it's parallel, the same way of doing it. As you can see, once you have understood the concept from what we have discussed earlier on, you can see that everything is kind of like a repetition. Don't you think so? This is just how you can get your parallel, your total resistance. Of also equivalently, you can get it by 1 over R and then 1 plus 1 over ZL. Alright, Ohm's law stays the same. This one as well. Alright, everything stays the same actually. You can see the formula is exactly the same. Alright, if it's RC, the same way, only that when you get the ZT, it will be equivalent to the formula of you getting it in parallel form. Alright, you want to get resistor across any, alright, as long as for parallel though, for parallel circuit, your V, because it's the same node, right? So if my V is 10 volt here, it's 10 volt here, it's 10 volt here. Alright, it stays the true as long as the node is the same. Usually for parallel circuit, the V that is shed across is the same. Okay, for series circuit, the current that flows through the circuit will be the same. So that's the two characteristics that you might want to take into account and remember. Real power, as usual, only taken into account your R. Reactive power, in this case, you only have your QC. Alright, so everything stays the same. If it's a combination of 3, you just get the parallel of 3 together, and then go by the Ohm's law again. Real power, only the R. Reactive power, you have the QL and your QC. Okay, and current divider rule, just now you mentioned, remember we learned about voltage divider rule, right? So for current divider rule is a little bit different in the sense that, let's say this is my Z1, this is my Z2. Alright, if I want to get my current over here, instead of taking my my Z over here, I take the Z of the other circuit. Alright, so that would be Z2 over the summation of my Z1 and Z2 multiply with my IT. Okay, you see the difference there? For voltage divider rule, whatever voltage that we want to get, that's the Z that we take into account, right? But for current divider rule, is the other way around. Alright, if I want to get the I1, the one on top that sit on top, my numerator will actually be my Z2. If I want to get my I2, it will actually be my Z1. Alright, divide by my Z1 plus Z2, and then multiply by my IT. So this is an example. I hope that you can give it a try on your own. Solution is actually given and all that already. By now you're very clear on why certain thing is 90 or why certain thing is negative 90. Remember, we have talked about this before in the behavior of our resistor. Alright, so just another refresh for everyone. If you want to talk about ZL, alright, whatever the ohm is, you always want to include a degree of 90 degree here. Alright, because just to indicate, because of the 90 degree difference and all that. What about XC? Alright, for XC, everything stays the same, but it will be negative 90 degree. Alright, so you just remember to include that in when you're talking about, or when you're calculating your ZC or your ZL. Alright, your ZR will remain the same. Okay, so that's one thing that you want to really pay attention into. Okay, so thank you so much for listening. I hope you guys actually enjoy this recorded lecture and stuff like that. Since we are not able to have the physical lecture for a while, I really hope that you guys watch all this, and then next physical class next week we will be able to discuss more on whatever that anyone has doubt on. Alright, see you guys soon. Thank you.